All right, for your astronomy unit, which is topic 4 and topic 3 in your review book, it's really important that you actually watch the videos that I post on your Google Classroom stream, along with read the topic 4 and topic 3 review book. So let's flip to page 62 and look at question number 1. Question number 1. If Earth rotated from north to south, the North Star would appear to. All right, I need you thinking. The Earth rotates west to east. And because of that, our sun appears to set in the west. Same concept. I just need you flipping. So instead of going west to east, we would rotate north to south. Now, the North Star is dead over the North Pole. With that one, it would, if we rotate north to south, it would appear to set in the north. Just like west to east, the sun appears to set in the west. Number 2. How would a 3-hour time exposure photograph of stars in the northern sky appear if Earth did not rotate? The whole idea of the stars appear to move in the night sky because we are rotating. If we didn't rotate, they would be stationary. So that would be answer number 3. Number 3. An observer took a time exposure photograph of Polaris and 5 nearby stars. How many hours were required to show the star paths? I need you to think it back. For a complete rotation is 360 degrees in approximately 24 hours. 360 degrees divided by 24 hours, we rotate approximately 15 degrees per hour. Need to keep that in mind. I'm going to have you do math. So if I'm looking at the star paths, I don't care which one you start with, 30 to 90, 120 to 180, the 240 to 300, or the 300 to 360. They're all 60 degrees. With that one, I'm taking the 60 degrees, dividing it by the 15 degrees per hour, and I can come up with 60 divided by 15, 4. So the whole idea is it's been 4 hours. Number 4. When observed from a location in New York State for an entire night, the North Star, or Polaris, appears to. Now, for us, here in the Northern Hemisphere, all the constellations, all the stars appear to revolve around Polaris. Polaris looks to be a fixed point. So with that one, 4, remain stationary in the sky. That's what the Polaris is going to do. Now, you should have picked that one up because you have been doing homework for me since September where you had a plot where the Big Dipper was. If you had gone out those 3 nights, you would have seen that the Big Dipper appears to be revolving around Polaris, which is at the end of the handle of the Little Dipper. Number 5. Explain why most stars seem to move from east to west across the sky in New York State. Again, that is because we're rotating west to east. So if I look at North America, the east coast of North America gets the sun first because we rotate west to east. So the western coast gets the sun last in the United States. So it has to do with the Earth rotating west to east. Number 6. The star Sirius is observed in the evening sky during the month of January. At the end of 3 hours, Sirius will appear to have moved. We're back doing math. So 15 degrees per hour times 3 hours, it's going to be 45 degrees. On December 21st, date really important, that's the one you underline. December 21st, at which latitude would an observer find the sun directly overhead? So going back to your notes, December 21st, we're looking at seasons. Where is the sun the zenith? That's 23.5 degrees south latitude, also known as the Tropic of Capricorn. Number 8. The sun's apparent daily movement across the sky is caused by, once again, the sun appears to move or revolve around us because we're rotating. So number 4, Earth's rotation on its axis. Now, number 9 does not have a correct answer on that. We need to talk about that one. At which location below would the sun produce an angle of 23.5 degrees relative to an observer's head at noon on June 21st? So June 21st, we know, is our summer solstice. The sun is directly overhead, or 90 degrees, at 23.5 degrees north latitude, Tropic of Cancer. For us here in central New York, the sun reaches about 71 degrees. All right, the only state that ever has the sun as a zenith is going to be Hawaii, because it's below the tropic of Cancer. So we need to go back and look at this diagram really quick. So if you notice, this one, it says you're looking at mid-latitudes. The sun is never directly overhead on this person because it's not 23.5 degrees. With this one, I need you flipping back. After your reference table in your review book, you have your appendix, and it talks about the performance test, and then you keep going and talks about landscape. And then you hit page A23 and 22. Alright, these will actually go over them. So here's my 90 degrees on June 21st, which is our summer solstice, and it actually tells you what its angle, the altitude of the sun, A, over here, in solar noon in degrees is, and then it's also talking about how much daylight you have, the duration of daylight. So if you're looking, the 23 degrees, 23.5 degrees is actually going to be at the North Pole. If I come over here, let's go 66.5 degrees north. This is the Arctic Circle. If I notice as I go down in latitude, my angle is increasing. Alright, so my only one that's going to be that low at 23.5 degrees is going to be the North Pole. They don't have the actual answer for you. Also note, the sun never sets because they have 24 hours of daylight on June 21st. So the answer should be 90 degrees north. You'll know it's not there. Remember, 23.5 degrees north, it's 90 degrees. Number 10. At 40 degrees north latitude, how many days a year is the sun directly overhead at noon? Remember, the furthest north it actually goes is the Tropic of Cancer. So at 40 degrees, which is 23.5 degrees, 40 degrees is never going to be overhead. So the answer is 0. Number 11. In New York State, to see the sun at noon, one would look towards the... Alright, so I'm in New York State at noon. If I'm looking back at my diagram on figure 4-3, those are going to be your sun at noon, your solar noon. Notice that you're always looking towards the south if you're the observer. Always going to be looking south because the sun is always going to be south of us, even on June 21st. A student in New York State obtained the data below by noting the altitude of the sun at noon for 3 consecutive months. The data for month Y were obtained during, alright, if I'm looking X to Y to Z, X is higher than Y, so Y is going to be my lowest and then starts to increase again. So for that one, if I'm in New York State, the lowest is possibly going to be, going back to the diagram, is going to be December 21st, known as our winter solstice. So the answer's got to be December. 13. To a person located at 43 degrees north latitude, the sun appears to rise due east on. Alright, so back to your diagram. Due east means you got to be right on the east, on that dotted line. So the only time you have that is going to be your equinoxes. So September 22nd, 23rd, or March 20th or 21st. So your answer is going to be March 21st, because it's an equinox. From September 21st to December 20th in the United States, the direction in which the sun sets. Back to the diagram. So, if I'm looking at this, after I have my equinox, end of September I'm moving this way. End of September, October, November, December 21st, I'm down here, it's my lowest. Alright, after December 21st, which is my winter solstice, it starts moving back this way. End of December, January, February, March, I'm back to my equinox March 21st or 20th, and then it moves April, May, June. June 21st I'm at my highest, and then I go July, August, back to September. So it's oscillating between those 2 points. So if I'm going to be sun setting on December 21st, here's west, it's going to be south of west. So my answer is number 4. Moves from the west towards the south. Okay, questions 15 through 19 actually refer to the diagram figure 4-5, which is geocentric. Geo meaning Earth, Earth-centered. Alright, you notice Earth is in the center, and everything is revolving around it, including all the planets, the moon, and the sun. Heliocentric, which is figure 4-6, is what we actually go with, where the sun is in the center and the planets revolve around the sun. So let's go on to question number 15. In a geocentric model, which motion would occur? Well, looking back at right at that diagram, the sun would revolve around the Earth. Number 16. Which diagram represents a geocentric model? Alright, like I said, it's basically the same thing that you just saw on the page right next to you. The Earth is the center, everything else is revolving around. Number 17. The apparent rising and setting of the sun, as seen from the Earth, are caused by... It looks like the sun is revolving around us. That's because the Earth is rotating. Number 18. Which diagram best represents a portion of the heliocentric model of the solar system? Alright, heliocentric, sun is in the center. So that's getting rid of 1 and 2. Now, here's a question. What is wrong with number 4? Number 4 has the moon orbiting the sun and the Earth orbiting around the moon. So it doesn't have the Earth orbiting around the sun. So that one is going to be out. So it's got to be it's got to be answer number 3. The Earth is orbiting the sun counterclockwise and the moon is orbiting the Earth counterclockwise. Number 19. Which planetary orbit model allows scientists to predict the exact positions of the planets in the night sky for many years? Well, we know we're heliocentric, it's getting rid of the geos. And the whole idea, if we look at our eccentricity, or how elliptical our orbit is, and that's on your reference table, page 15. If it's a perfect circle, eccentricity would be 0. It's not 0 for any of them, so they're going to be ellipses or ovals. So the answer is going to be planet orbits are ellipses in the heliocentric model. Question number 20. The following diagram represents part of the night sky, including the constellation Leo. The black circles represent stars. The unshaded circles represent a changing position of one celestial object over a period of a few weeks. The celestial object represented by the unshaded circles most likely is. So if I'm looking at the unshaded, you'll see 1, 2, 3, 4, 5. They're moving in one direction. And all of a sudden 6 seems to be coming backwards. That's because that celestial object is in retrograde. And retrograde is caused by that change in gravitational attraction between the planet and the sun. So the whole idea, the further it gets away, the planet gets away from the sun, the less gravitational attraction, the slower it goes. So what's happening is the planet is your unshaded. Alright, it's gone into retrograde. It's slowing down. Number 21. Why are different constellations visible in the night sky at different seasons of the year? That's because your frame of reference is different. The stars are out right now during the day. Problem is it's too dark, you can't see it. So if you actually stand up and you look straight ahead and say, there are my summer constellations, you only see them at night. So your face will say it's night. If you rotate and you look 180 degrees on the other side of you, you'll see the winter stars. Alright? They're out during the summertime, but it's daylight for you. So you're not going to see them. So it has to do with your frame of reference is different. Because we are revolving around the sun. Number 22. An angle of 23.5 degrees is formed between the axis of Earth and the line of the perpendicular to the plane of the Earth's orbit. So take a 90 degrees angle coming right out of the North Pole, and if I tilt it to 23.5 degrees, that's going to give us our actual tilts. 23. The Foucault pendulum provides evidence of the Earth's, straight out of your notes, and I also did a video for you. That's rotation. On Earth, surface ocean currents rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere because of the Coriolis effect. That one too, straight out of your notes, and you also had a video on it. Base your answers question 25 and 26 on the following diagram. The diagram shows the course of a year, 12 constellations that are visible in the night sky to observe in New York State. Different positions of Earth are represented by letters A through D. The arrows represent the direction of the Earth's motion around the sun. Notice we're counterclockwise. We only see the stars again at night. So 25. Which constellations are both visible at midnight to an observer in New York State when Earth is located at D? So if I look at D, location D, I need to have the side that's facing the dark part of the Earth. So my answer is going to be Leo and Virgo. The other ones, too bright out, not going to see them. 26. The constellations observed from New York State when the Earth is in position A are different from the constellations observed from New York State when the Earth is in position C, because this is, again, same question that we had earlier. The Earth moves in its orbit because it's revolving. Question 27. Which statement provides the best evidence that the Earth revolves around the sun? These are dead out of your notes. Your answer is seasons of spring, summer, fall, and winter repeat in a pattern. Remember, how do we know that we revolve around the sun? Seasons and season constellations. Question 28. Traditionally, most units of time are based on, we're egocentric, so it's all about us on the Earth. The day is how long it takes the Earth to rotate, a month is how long it takes the moon to revolve around the Earth, and a year is how long it takes the Earth to revolve around the sun. So it's all about the Earth. 29. If Earth's rate of rotation decreased, there would be an increase in, our day is actually getting longer as the moon is moving further away. You had a question on that in geological history. The whole idea during the Devonian time period, there were actually 400 days per year. Now as the moon moves away, the day is getting longer. Number 30. How long does Earth take to complete one orbit around the sun? That's a year. That's what our year is based on. 31. Units of time are based on the Earth's motion relative to other celestial objects. The year is best defined as the Earth's motion relative to the sun. How long it takes the Earth to revolve around the sun. 32. According to the diagram below, the time of point C is closest to. Now I need you looking at this diagram. You'll notice that you had an aerial view over the North Pole. Notice half of the North Pole is dark, half is illuminated. So half and half, 12 hours daylight, 12 hours darkness, you know it's an equinox. So with that one, we're rotating counterclockwise. So if I am at location C, I'm leaving the light, I'm going into the dark. So that is going to be, my sun is setting, so 6 p.m. Here would be noon. Here would be 6 a.m. We're going into the sun or sunrise. And here would be midnight. 33. Cities located on the same meridian must have the same local solar time. Doesn't mean they're going to have the same amount of daylight. It just means their solar noon is going to be the same. Question 34. When does local solar noon always occur for an observer in New York State? This is dead out of your nose definition. Solar noon is when the sun reaches its maximum altitude or its highest point in the sky. Base your answers question 35 through 37 on the following diagram on Earth. Some of the latitude and longitude lines have been labeled. Points A through E represent locations on the Earth's surface. What do locations A, B, and E have in common? Well, they're the same longitude, so if they're the same longitude lines, then they have the same local time. 36. The latitude and longitude of which location is closest to that in New York State? Now, I need to go back to your reference table. Page 3. You have latitude and longitude on your reference table. So remember, latitude-wise, we're about a little over 40 to 45, and longitude-wise, 73 to about 79, a little more than 79. So you're going back, and the location that hits that is going to be location C. You're around 40 in the lower 40s, and you're also in between the 60 and the 90, which would be our 70s. So location C. 37. What is the approximate time at location D? So once again, I'm looking at the North Pole. Half is illuminated, half is dark, so it's an equinox. I am rotating counterclockwise, so I'm going from the dark into the light, so it's got to be 6 a.m. Ship X and Ship Y are sailing across the equator. The difference in local solar time between their locations is 2 hours. What is their difference in longitude? Now, I know you guys actually looked at the diagram over here, and it talked about, on figure 411, time zones on Earth. There are 24 time zones, each 15 degrees of longitude in width. So if you know they're 15 degrees apart, 2 hours, 15 times 2 is 30 degrees. Base your answers to questions 39 and 40 on the following time zone map. What is the time in San Francisco when it is 6 a.m. in Dallas? So if you look at the clocks up here, they're telling you here is Dallas, here is San Francisco. San Francisco is 2 hours behind Dallas. So doing the math, 6 minus 2 gives me 4 a.m. The dashed boundaries between the time zones are how many degrees of longitude apart? We just read it in your diagram, figure 411. That's 15 degrees. Now, if I go back here, this in your notes, but it's also very handy for you to look at or review back. Remember, half of the moon is always dark, half is lit. The side facing the sun is always going to be illuminated. Your angle or my perspective from Earth is going to change as the moon revolves around the Earth. So, base your answers to question 41 through 47 on the following diagram. The diagram represents the moon in various positions in its orbit around the Earth. Letters A through E represent 5 of the moon's positions. Number 41. Which diagram best represents the appearance of the moon to an observer on Earth when the moon is at position B? Alright, so this is what I do. Like I did on your notes. I draw my 2 parallel lines around my moon. Here's my arrow. This is what I'm seeing. This is me from Earth looking that way. So if I'm looking, there's my left, here's my right. I'll notice most of it's dark. Just a sliver on the right is illuminated. So that means it's going to be option number 2. It's a waxing crescent. Number 42. The moon would not be visible from Earth when the moon is at its position. Well, that would be position A because it's dark. Although in reality you actually can see a new moon. It's just not illuminated. You see it during the day. 43. Why would an observer on Earth see a complete cycle of phases of the moon in approximately 1 month? That's because that's how long it takes the moon to revolve around Earth. Dead out of your notes. 44. If the distance of the moon from Earth were to increase, the length of time the moon would take to complete 1 revolution around the Earth would also increase. The further something gets away, the longer it's going to take to move around something. 45. How does the moon appear to an observer in New York State when the moon is at position E? Going back, looking at position E on your diagram. Now, it looks to the left side is dark and the right side is illuminated. What you need to remember is you're looking from the Earth. So, easiest thing to do is actually rotate. So if I look at position E, it's the left side that's illuminated and the right side is dark. So that one is going to be choice 2. 46. The shadow of the moon may fall on Earth at position A. So if the shadow is falling on the Earth, this is going back to you figure 417. The shadow is falling on the Earth when the moon is at a new moon. At which positions of the moon do the smallest high tides occur on Earth? Well, that's out of your notes. We talked about neap tide. Small is your lowest high tides, highest low tides. That's going to be your quarter moons. Alright, so that's C and E. 48. If a full moon occurs November 1st, the next full moon phase will occur about... I need to think it back. Your reference table says 27.3 days. That's how long it says period rotation revolution is. That tells you, the only thing you got to remember for those is that's why we always see the same side of the moon. What that number doesn't take into account is that the Earth is also revolving around the sun at another 2.2 days. So for a lunar cycle to occur, it actually is 29.5 days. So with that one, add 29.5 days to 1, comes out with 30.5. Your closest answer is going to be November 30th. 49. In an open ocean, a bulge of water 2 to 3 feet high that follows the moon's movement around the Earth it's a tide. 50. The following diagram represents a north polar view of the Earth in relation to the moon and the sun. The tides that occur when the sun, moon, and Earth are in relative positions indicated by the diagram are best described as, alright, the sun and the moon are aligning with the Earth. So that means the sun and the moon are working together. So they have the strongest pull. So you're going to have your highest high tides and your lowest low tides. So if I'm looking at that one, you guys are going to be the sun, and I'm going to have the moon over here. So what's happening is you guys are pulling water from this direction, this way, that way. So here's going to be my high tides, and over here is going to be my low tides. So as this rotates, about every 6 hours, a little over every 6 hours, I go from a high tide to a low tide. So with that one, it's going to be my highest high tides and my lowest low tides because they're working together. So that's known as the spring tide. 51. A high tide occurs at Boston on a certain day at 3 p.m. The next high tide will be expected to occur at, alright, you're looking at a little over 12 hours later, so add 12 to that. You're going to be at 3:26 a.m. the following day. During which event does the moon receive the least amount of sunlight? That one, if I'm looking back at the figure 4:16, the moon is dark up here during a total lunar eclipse. So my answer is going to be a lunar eclipse because I'm not getting any daylight. 53. During which phase of the moon do solar eclipses occur? That one, solar eclipse, going back to your diagram, your solar eclipse, you got to be a new moon. Lunar eclipse, full moon, solar eclipse, new moon. The following diagram represents the landscape on the moon with the Earth shown in the background. Use this diagram to answer questions 54 through 57. As viewed from the Earth, what is the phase of the moon? So if I was going back to that diagram over here, it's the same concept. The whole idea is I noticed that half of the Earth is dark, half is light, and I'm looking at the moon, so it's going to be a quarter. With respect to the diagram, which statement is true? Quarter moons, I don't have an eclipse, so no eclipse could occur. 56. In the week following the period shown in the diagram, the amount of the moon's surface that is illuminated by the sun, well, it's always 50%. So they're not asking about phases, they're asking how much of the moon is actually illuminated. 50% always, so it's going to remain the same. 57. What is the most probable cause of the lunar feature indicated by A? So if I'm looking at A is a crater. Craters are caused by collisions of asteroids, meteoroids, or comets.